duration in the context of a CBEMA curve refers to the length of time for which the voltage remains below a specific threshold. That threshold is typically 90% of the nominal voltage. Therefore, it is not the entire period from the moment a disturbance begins until it completely dissipates. A CBEMA curve, which stands for Computer and Business Equipment Manufacturers Association curve, is a graphical representation illustrating the voltage tolerance of electronic equipment when subjected to power disturbances. It is a tool used to evaluate how susceptible devices are to voltage sags, which are brief reductions in voltage, and interruptions, which are complete losses of voltage. The curve plots the minimum voltage level that a piece of equipment can withstand for a certain period without malfunctioning or losing functionality. The duration aspect of a CBEMA curve is usually quantified in milliseconds. This represents the time frame during which the voltage remains depressed below the established threshold. For example, if a CBEMA curve specifies that a device can handle a voltage set down to 90% of the nominal voltage for a duration of 100 milliseconds, it means that the equipment should continue to operate normally even if the voltage dips to 90% for up to 100 milliseconds. If the voltage remains below that level for longer than 100 milliseconds, the equipment might experience problems. The duration of a voltage sag is measured as the time span during which the voltage stays below that predefined level. Similarly, the duration of a voltage interruption is the time during which the voltage is completely absent. The duration of voltage sags or interruptions is a critical factor to consider when designing and installing power systems for sensitive electronic equipment. It informs decisions about what kind of protection is needed to ensure reliable operation. Equipment that is particularly susceptible to voltage fluctuations should be protected. This protection can take the form of surge protectors, which guard against sudden voltage spikes, or uninterruptible power supplies, which provide backup power in the event of a complete power failure. Using these protection devices can mitigate the effects of voltage disturbances and ensure that sensitive equipment continues to function correctly. The CBEMA curve is used to assess the immunity of equipment to voltage variations. The curve specifies the magnitude and duration of voltage sags and swells that the equipment can withstand without malfunction. It plots voltage against time, showing acceptable operating regions for electronic devices. The CBEMA curve is useful for ensuring compatibility between equipment and power systems. There are other standards that relate to power quality and equipment immunity, such as the ITIC curve, which replaced the CBEMA curve, and SEMA F47. These standards provide guidelines for voltage tolerance and disturbance levels. The ITIC curve is an updated version of the CBEMA curve, offering more comprehensive guidelines. SEMA F47 specifically addresses voltage sag immunity for semiconductor processing equipment. Understanding these standards is essential for electrical engineers, system designers, and anyone involved in ensuring the reliable operation of sensitive electronic equipment. The goal is to protect equipment from damage or malfunction due to power quality issues. Power quality refers to the characteristics of electrical power that affect the functioning of electrical equipment. Poor power quality can lead to equipment failure, data loss, and other problems. Common power quality issues include voltage sags, voltage swells, harmonics, and transients. The CBEMA curve helps address voltage sags by specifying the acceptable duration and magnitude of voltage dips. Voltage sags are short-term reductions in voltage that can cause equipment to malfunction. Voltage swells, on the other hand, are short-term increases in voltage that can also damage equipment. Harmonics are distortions of the voltage waveform that can cause overheating and other problems. Transients are sudden, short-duration bursts of energy that can damage sensitive electronic components. To mitigate power quality problems, various solutions can be implemented, including surge protectors, uninterruptible power supplies, voltage regulators, and harmonic filters. Surge protectors protect against voltage spikes, while uninterruptible power supplies provide backup power during outages. Voltage regulators maintain a constant voltage level, and harmonic filters reduce harmonic distortion. In addition to protecting equipment, improving power quality can also reduce energy costs and extend the lifespan of electrical equipment. Therefore, It is important to regularly monitor power quality and take corrective actions when necessary. The duration parameter in the CBEMA curve is crucial because it defines the time frame within which the equipment must tolerate a voltage sag without experiencing any adverse effects. The magnitude of the voltage sag is also important, but the duration determines how long the equipment must withstand the reduced voltage level. For example, a brief voltage sag of a few milliseconds may not cause any problems, but a longer voltage sag of several seconds can lead to equipment malfunction or failure. The CBEMA curve provides a framework for specifying the acceptable duration and magnitude of voltage sags for different types of equipment. This information is used by manufacturers to design equipment that is more robust and less susceptible to power quality problems. It is also used by power system designers to ensure that the power supply is adequate for the equipment being used. The curve helps match equipment capabilities with power system performance, minimizing the risk of power-related issues. Power quality monitoring is an essential part of maintaining reliable electrical systems. By monitoring voltage levels, harmonics, and other power quality parameters, potential problems can be identified and addressed before they cause equipment damage or downtime. Power quality monitoring equipment can range from simple handheld meters to sophisticated online monitoring systems. The data collected from these systems can be used to identify trends, diagnose problems, and optimize power system performance. Regular power quality monitoring can help prevent costly equipment failures and ensure the reliable operation of critical systems. The application of CBEMA curves also extends to data centers, industrial plants, and other facilities where sensitive electronic equipment is used. In these environments, even brief power disturbances can have significant consequences, such as data loss, process interruptions, and equipment damage. By understanding and applying CBEMA curve principles, facility managers can implement appropriate power protection measures to minimize the impact of power quality problems. These measures may include installing uninterruptible power supplies, voltage regulators, and surge protectors. They may also involve improving grounding and bonding practices, and implementing regular power quality monitoring programs. A well-designed power protection system can significantly improve the reliability and uptime of critical facilities. The CBEMA curve is a valuable tool for assessing the vulnerability of electronic equipment to voltage sags and interruptions. The duration parameter of the curve is critical for determining the acceptable length of time that equipment can tolerate a voltage sag without malfunctioning. By understanding and applying CBEMA curve principles, electrical engineers, system designers, and facility managers can improve power quality and protect sensitive electronic equipment from damage or failure. This ultimately leads to increased reliability, reduced downtime, and lower operating costs. In summary, the duration in CBEMA curves is not just about when a disturbance starts and ends. It focuses on how long the voltage remains below a certain acceptable level. It helps assess equipment's ability to handle voltage dips. This is important for protecting sensitive electronics from power issues.